Hello friends, today's question: a string of length 0.4 meter and mass 10⁻⁻² kg is tightly clamped at its end. The tension in the string is 1.6 Newton. Identical wave pulses are produced at one end at equal intervals of time. This has to be delta t. The minimum value of delta t, which allows constructive interference between the successive pulses, is. So we have to find out, you can say, the difference between the identical pulses such that results in the constructive interference between the successive pulses. Okay. So let us start from this statement only, that for a, you can say, in order to find out the time interval delta t, we are going to find out what will be the fundamental frequency, and this fundamental frequency is going to give us the time taken or time between the successive pulses to produce a constructive interference. So we start from the statement itself, the question itself, that the minimum time interval which we are supposed to call as delta t for constructive interference between successive pulses between successive pulses. So this will be given as with the help of calculating the fundamental frequency. So we can say that fundamental frequency gives us the time taken for a pulse to travel down the length of the string and return back. Travel down the length of the string length of the string and a return, which is this is the basic of your, you can say, constructive interference. You can say this is the basis of constructive interference. So it means we are interested in finding out the fundamental frequency, and fundamental frequency is given as V upon 2L. Fundamental frequency of the string frequency of the string, let us denote it as F. So this F will be equal to V upon 2L. V upon 2L, and we are going to find out this V, and where V is nothing but wave speed of the string. V is the wave speed on the string. And this V is given as square root of T divided by mu. T is the tension in the string. Tension in the string, and this mu is linear mass density. Linear mass density, and which we calculate by using the length as well as mass that is given to us. So we can say mass divided by length. Mass is given at 10 to the power minus 2 and length is given as 0.4, and this comes as 0.025. So we can write that velocity tension is given to us 1.6 divided by 0.025. So this gives us that V is equal to over 8 meter per second. So we got the value of velocity, and length we already know. So basis of this we can find out the fundamental frequency, that is our F. Therefore F will be equal to V upon 2L, that is 8 upon 2 multiplied by 0.4, and this gives us 10 Hertz. And now we are going to find out our delta T, which in the question it is given as minimum time interval. Minimum time interval, whichever delta T, and we have to find out it for a constructive interference. So we say for constructive interference, the successive pulses need to be produced in such a way that they are separated by a time interval which is equal to the period of the fundamental frequency, such that they are separated by a time interval equal to the period of fundamental frequency, equal to the period of fundamental frequency. So we can say the minimum time is delta T, and delta T should be equal to period of fundamental frequency, which will be equal to nothing but 1 upon F. So this we get 1 upon 10, and it will be coming as 0.1 seconds. So the options that are given to us, we can say option number B is the correct option. Option B is correct. On the question we were only asked for the constructive interference, but we can just extend the same question into destructive interference also. And for destructive interference, it should be produced, the time interval should be half of the period of the fundamental frequency. Okay, so let us extend it into for destructive interference. for destructive interference, so we are going to write same thing, but they should be separated by half the period of the fundamental frequency. Okay. You can say the pulses need to be produced at a time interval that is half the period of fundamental frequency. So which basically means that this is going to ensure rather that the second pulse arrives half a wavelength out of phase with the first. So this will make sure that the destructive interference takes place. So you can say this makes, and this would ensure that second pulse arrives half a wavelength out of phase with the first pulse. The first pulse leading to destructive interference. Leading to destructive interference. And for that, let us call this time period as delta t destructive, so that will be equal to t divided by 2, where this t is the time period of the fundamental frequency, and which we know we just calculated it as 0.1, so we can use this value, or we can also write this as 1 upon 2f, and this becomes 1 upon 2 multiplied by 10. So ultimately it will be 0.1 divided by 2. So this gives us delta destructive will be equal to 0.05 seconds. Okay. So destructive interference time period successive between the successive pulses is also dependent upon the time period of the fundamental frequency. Only difference is that it is half of the time period, whereas in this case the delta t is simply equal to capital T, okay, which is the time period of the fundamental frequency. So this is a major difference between the two things. So this completes the question. Thank you.